Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College presenting OpenStax Principles of Economics, and today we're covering sections 8.1 and 8.2. In this module you will learn how to describe perfect competition, define total revenue, total cost and profit, calculate average and marginal revenue, cost and profit, and analyze revenue, cost, and profit on average and at the margin. You'll notice this doesn't cover all of the OpenStax book section 8.2. Our next module will also include some 8.2 content. So at this point in our study of economics, we want to use the tools of economics to make sense of decision making at the individual firm level. And how that works depends on the market structure our firm finds itself in. Today we start on one extreme of those market structures, perfect competition, where we have many firms selling identical products, until later we look at the opposite end of our extreme with a monopoly, having just one firm and no competition at all. In between these extremes, you will see some more commonly analyzed market structures, such as, for example, firms that have differentiated products, or just a few firms that offer identical products, the oligopoly. But of course, there are other types of mixing and matching. You can also have few firms that have differentiated products, or even markets that are characterized by buyers being particularly powerful, so-called monopsonies. But for now, let's talk about perfect competition. So this is a logical starting point for us in economics because, among other things, it's one that's a little bit easier to analyze. It's a little bit like talking about physics and we don't have any friction going on. There are some assumptions we want to be aware of that are being made and see how applicable they are to the situation we're analyzing. This isn't comprehensive, but these are the big ones we'll be talking about. So in a perfectly competitive market, we have many buyers, many sellers. Nobody individually dominates. They are not just selling undifferentiated products. When we say perfect competition, we mean literally identical products. Nobody cares who they buy or sell from. Like, maybe you've got a bit of land with some oil on it. You operate an oil well. You can decide how much oil to pump, sure, but when it comes time to selling it, nobody really cares if they buy that oil from your well or somebody else's, as long as it, is the same general type of oil. And then something that's a little less talked about, but we'll be taking advantage of these as well. It does need to be a market where the buyers and sellers both have full access to the relevant information about the product to make good decisions, so nobody can sort of be tricked or anything. And also there needs to be free entry and exit, meaning new firms can enter, existing firms can leave. That's going to be important both from a perspective of what happens if the size of the market changes and also from the perspective of cost control, but that's going to be for the next module. So within this context of perfect competition, let's get started and talk about what it means to be an individual seller in this market. Individual sellers here are so-called price takers. What that means is there exists a price for the product, like that oil, and the individual seller can't do anything about it. So if they want more for their product, no, nobody will give them more. And they could sell for less, but why? Because from their small perspective, they can sell an unlimited amount at the existing price. If we want to draw this up as a demand curve, the demand curve an individual seller faces in a perfectly competitive market is horizontal. There is a price. At that price, this seller can sell any amount they wish. You'll recognize this from our previous module. This is a perfectly elastic demand curve. Now, important distinction here. From the perspective of the individual seller, if we look at the market as a whole, of course, we'd expect the market as a whole to have some sort of downward sloping demand curve, depending on how much of a need that product is. But that's not what an individual seller sees, so to speak. Or putting the statement on its head. Even if you have a product that's very much a need, like let's say housing. So we look at the market. In the market, demand curve, very inelastic, very steep. That doesn't mean an individual seller is going to have a ton of pricing power. That depends on how much competition that seller faces. And if it's highly competitive, then they still don't have any power, because if they raise price, somebody just gets an apartment from somebody else. All right, same story on the buyer side. We also call them price takers. There's a market price. At that market price, they can buy as much as they want, and they can't get it for any less. Nobody will sell to them for any less, and no reason to buy for any more, right? So from the perspective of the individual buyer, they're facing a perfectly elastic horizontal supply curve here, which of course doesn't mean that the market as a whole has a perfectly elastic supply curve. That can and again should be expected to upward slope. So I'm drawing an important distinction here. The perspective of the individual buyer and seller, completely responsive. That the market sets a price, we're going to figure out how to react to that price. The market supply and demand curves, they determine that price. So we still have a standard supply and demand model that describes the market as a whole. For the rest of today, we're going to be talking about some raspberry sellers at the market selling packs of raspberries. There's some, global amount of raspberry sellers and buyers here. They determine an equilibrium price in the market. Let's say that's going to be $4 for the rest of today, leading to a total amount being sold of 800 packs of raspberries. And now our individual firm is going to go ahead and react to that market price. Let's get to it. So our individual firm, we are going to be looking at from the perspective of profit, revenue, and cost. Underlying reason we're doing that is because we're going into this with the assumption that it is the goal of the firm to maximize its profit. Number one, that is in fact the goal of many firms, to earn a profit, right? And even though you can run a company with an objective other than maximizing a profit, nevertheless, the tools of profit maximization will still be important to know about. So when we talk about profit, this is not the same as the revenue of a firm. Revenue is how much money the customers give to the firm. That's the sales of the firm, the turnover of the firm. The profit, it's what's left of those revenues after you've subtracted all the costs of the firm. So we have that written out here nicely using words. Profit is total revenue minus total cost. But often, just for space constraints, we're going to be using completely standard symbols as well. In economics, we use TR to denote total revenue, TC to denote total cost. And the only oddball you'll see here is that lowercase pi. How'd that sneak in here? Well, P is typically taken in economics to denote the price. And we don't want to accidentally confuse between price and profit. So the common abbreviation for profit in economics is the letter pi. We're just using it as a letter here, not as the mathematical constant, 3.14, blah, blah, blah. We're just using it as a placeholder. And then within total revenue and total cost, I've got a little bit more for you. So when it comes to total revenue, for today, we are only going to be looking at companies where every unit sells for the same price. Always the case in perfect competition, sort of by definition, there's one market price. Also in less competitive market types, it's entirely possible, even if a firm has tons of power, that nevertheless it will sell products at the same price to everybody. And if that's the case, if we have one price, then revenue is super easy to calculate. It's that price that's being charged times however many units the firm is selling, P times Q. And then over on the cost side here, total cost of a firm, we often subdivide that into two component types of costs, terms that may be familiar to you. FC for fixed cost, VC for variable cost. If they aren't, I'll explain those to you in just a minute. But let's start out by having a closer look at the revenue of a company, because that's the easiest part of a perfectly competitive firm. So if we're selling just one price, and that's what our Raspberry firm here is doing, no matter how many Raspberries they sell here from 0 to 100, always being sold at a constant price of $4, then our total revenue is simply the product of how many are we selling, let's say 30, times $4 each, that's $120 coming into the business. Let's do it one more time. 60 units being sold, $4 each, $240 coming into the business. Price times quantity, total revenue, end of story. If we graph this, we end up with a straight line that goes through the origin. So down here, we've got how many units are we selling. Here we've got the revenue of our company. If we are a price taker, every time we sell more units, it just completely constantly increases our total revenue. You might even recognize from the last module, if we have a straight line going through the origin, that line is unit elastic. So change in total revenue on a percentage basis is equal to change in underlying quantity on a percentage basis. If you sell 20% more units as a price taker, then your revenue is going to go up 20%. Next, let's have a look at our cost. So these numbers are new. Just, an example of a cost structure for this Raspberry Merchant. For each level of production here, you will see both fixed and variable cost. Add them up, they have to equal your total cost. So for example, at a level of 20 units, 62 fixed, 48 variable, for a combined total of $110 total cost. Now there are a couple of things that are going on here I want to talk about. Fixed and variable cost are the subdivisions you want to make for all the cost of your business. Fixed cost, like the name implies, are costs that are the same, regardless of how much you're producing. Including, look all the way at the top of the table, we have a fixed cost here associated with zero quantity. What's going on with having zero quantity in our table? Well, when it comes to our decision making, one type of decision we'll be looking at is if sometimes we want to shut our business down. That doesn't mean to get rid of a business, that simply means to close the doors for a bit and then reopen later. That's what the zero row in our tables represents. Not that the business is gone, but that it's simply closed at the moment. Examples would include, do you want to be open 24 hours or do you want to close at night? Or maybe it's a seasonal business. Is there an off season where for a couple months your business is closed and then during the season for a couple months your business is back open? The fixed costs exist even during shutdown. In fact, there's something definitional going on there. Because if we look over at the variable cost of the business, so that's all your not fixed cost, by definition, variable costs are zero when you are shut down. So what that means is when you've got your total cost of the business, you have to be able to divide that real clean. Every dollar has to be allocated. Is this a fixed cost or a variable cost? If you've got a bill and you look at it and you're like, well, it's somewhat fixed, but then it starts changing, we're not done with those numbers. So for example, you might look at your electric bill and say, well, there's a certain base charge my business pays, even when it's closed. But then when I'm running my business, I've got some machines in there that consume extra electricity, so my electric cost goes up. Well, time to split that bill up. All the costs that exist when it's closed, by definition we call the fixed, and then the variable is only the costs that increase beyond that baseline. In fact, that means if you've got your total cost, you can actually derive your fixed and variable straight from that. You just look at your total cost in shutdown, that is your fixed cost, and you're done. Because that fixed cost is going to be the same number all the way down. And what remains? Well, those costs must be variable. All right, so we have looked at the total revenue and the total cost of our example business here for starters. Looking at it on a graphical perspective, you might have noticed that this total cost started out increasing slowly and then started increasing quickly. This is very common because most businesses, at least in their day-to-day decision making, have some sort of constraints where if you start running into them, things get very expensive. You run a small factory. Eventually, you're running at capacity. You want to run more product, you're going to start paying overtime. It starts costing a lot of money. You run a coffee shop. It's of a limited size. You can only get so many customers through efficiently. Beyond that, you're going to have to start complicated things like running people outside of the store to deliver coffee or something like that. Your cost goes up. It's not to say that these constraints always exist. In the next module, we'll also look at decision making beyond the constraints when everything is variable. But for starters, most day-to-day decision making is happening within some type of box, so to speak. So if we put our revenue and our cost together now, we can calculate the profit of our company. Notice, can be positive or negative, right? Easy example here, shutdown. Shutdown, by definition, no revenue, but fixed cost. So negative profit number. Economists often refer to losses as negative profits. Now, if you're a bit of a business person, your mind might already gravitate down this profit column here to the numbers that are biggest. Actually, two different rows here that have the biggest number. We're going to talk about that as well. At levels of 70 and 80 packs of raspberries sold. We will talk about maximum profit. Not yet. Today, we are learning the mechanics of how revenue and cost behave. So let's start looking at a slightly less exciting row like production level 60. Still profitable, still profitable. So revenue minus cost is our profit. And if we take everything we've looked at so far, our totals, and we were to graph them together, we could draw a very comprehensive picture of our business. So here one more time is our total revenue line. Straight line through the origin. Then we had our total cost. Increases slowly, increases quickly. And the difference between those two defines the profit of our business. So we see some major regions here. At first, when our business is operating at a very low level of production, making losses, cost above revenue. And eventually, when we are operating at a very high level, beyond 100 even, that was represented in the table, cost starts exceeding revenue, we're making losses again. But then in between, we've got a profitable level of production. And the amount here of profit varies. It's not like you're earning the same everywhere in between these two levels of production. The distance between the numbers grows and shrinks again. Looking at a specific example highlighted in the previous table, 60 packs of raspberries sold give us a profit of $75 difference between revenue and cost. Alternatively, you could even graph profit as a separate line, illustrating the difference between the revenue and the cost curve. So on some level, this already is the profit analysis of our business. But the approach here is very brute force, if you will. We are laying out the totality of all information, revenue and cost, for all possible production levels. A lot of daily business decision making will not come at it from such a comprehensive perspective where you can then just sort of grid search down, okay, where's the profit the highest? In fact, depending on your level in the organization, you might not even have access to all these types of information, right? Like you're running like your small retail branch and You start asking questions about, hey, can I get some like cost projections of what would happen if we shut it down for a month? Ooh, people might start asking some questions about like, what are you up to here, right? So more often for day-to-day decision making, instead of putting all the information on a graph at once, we're adopting a bit more of an inside-out perspective into the operation of our business, where we look at our current level of operation, and then we are looking at a per unit basis. Okay, what's happening to our revenues per unit, our cost per unit? Can we identify some directions we want to go in to make things a little bit better? That's going to be our focus here for the rest of today. Look at this same phenomenon for our business on a per unit basis. And when it comes to per unit, there are two major perspectives we have in economics. One, I venture to say, is very familiar to you. The idea of an average. You've probably calculated a lot of averages in your life already. So an average is when you take something and divide it by some other quantity. So you've got some number x you want to average, you take that number x, and then you divide it by some quantity. Our quantity here, when we talk about the production of our businesses, is going to be, the quantity we had labeled quantity, how much the business is producing, literally the quantity. But, averages, of course, can be defined in general in terms of many types of quantities. But then there's a second per unit type of analysis in economics. Maybe it's not so familiar to you. It's called marginal analysis, or thinking at the margin. It's also per unit, but not on average. At the margin, we're asking, when something changes, when x changes, how much does it change? Notice the Greek letter delta here, in response to a changing quantity. You'll always recognize a marginal as delta over delta. So we will look at both of these approaches in depth now, but I want to give you the big picture of why they are going to be relevant. Marginals. You're asking one step forward, one step backward. How is something changing? This is a great technique for finding an optimum, finding some sort of, efficient allocation. So for example, when it comes to how many raspberries do I sell to maximize my profit in the next module, we will use marginal analysis to identify that point. But while marginals are great by showing us what happens when we take one step forward, one step backward, they, are operating at this very small scale. They can't tell us whether overall things are looking good or bad. That's where the averages come in. Averages will tell us whether something is worth doing in the first place. And we'll use them to answer questions about whether our business should be open, closed, or maybe we should be going out of business. So let's just start looking at our concepts today, revenue, cost, and profit, from both perspectives. We're going to start out on the revenue side. Revenue per unit, when it comes to perfectly competitive businesses, ends up being super simple. This is why perfect competition is a great starting point. So let's start on the average side. In general, when you're defining an average, you say, take the thing. So right now we're going to talk about the revenue of our company, TR, total revenue, divided by quantity. But if you look at a business that charges the same price for every unit of its product, then total revenue, you can actually write that as a formula, that's the price of the product times the quantity sold. And perfectly competitive companies, they definitely sell at a single price. There's one market price that's just given. But even other firm types, even firm types with tons of market power, might be selling to everybody at the same price, which is why it's just super common for average revenue to work out in a predictable way. total revenue price times quantity, divide by quantity. You see what's happening here. The quantities are going to cancel. As long as you're charging a single price, average revenue simply is the price of the product. As a consequence, you'll even hear people not use the term average revenue that often. They'll simply use the term price, unless you're talking about multi-pricing. It just doesn't make a difference. Marginal revenue also has a simplification, but that one is specific to perfect competition. So it's not nearly as general as this average revenue equals price thing I just showed you. So marginal revenue, look at the definition, change in total revenue over change in quantity. But if we are in perfect competition, and this is specific to being a price taker, this is specific to perfect competition, we can simplify that further. Because we can take price times quantity, and we can take the delta of it, and it's going to give us a very specific result. Now, I can explain this result to you, using the underlying logic. And we're actually going to do a math example to demonstrate why marginal revenue behaves the way I'm about to tell you. But a few of you, maybe many of you, might be familiar with the underlying math as well. So if you are, this one is for you. And if you aren't, don't worry. It's not like I'd expect you to do this yourself. Just maybe enjoy the deltas, count how many there are, and just have a good time while we get to our result over here on the right. So if you take the delta of the product of two variables, that can be expanded as follows. You take the total of each variable times the delta by the other and add them up. So price times change in quantity plus quantity times change in price. And you add to that the product of the deltas, delta P times delta Q. So that's the expansion of our top row here. In the denominator, we still have delta Q. Now, how does that simplify anything? Well, it does if we're looking at a perfect competitor. A perfect competitor is a price taker, meaning what is the change in price? What is the delta P if a perfect competitor changes how much they sell? Answer, 0. A perfect competitor has no influence on the market price. No matter how much they sell, price doesn't change. And that really blows up this formula, because let's take these delta P's and plug in zeros for them. What do we find? Well, this product zeroes out. This product zeroes out. All we're left with is price times delta Q over delta Q. And again, we can cancel. And what do we find? Once again, the variable price. So when it comes to per unit revenue, for perfectly competitive firms, there's a very strong uniform result. Average revenue is simply the price of the product. Marginal revenue is simply the price of the product. But that second one, marginal revenue is the price of the product, that's unique to perfect competition. So don't get too attached to it. We'll take advantage of that today. Other times, we'll actually have to calculate it. Which means I do actually want to show you how to calculate this thing, even though it'll just have the most predictable result in the world here when we look at our Raspberry firm. So here's our Raspberry firm. For our tables, we are letting it produce between 0 and 100 packs of raspberries. And each of those packs is selling at a market price of $4 that we have no control over. Now you already know the price of that product will also be the average revenue. But let's work it out, right? To get from price and quantity to total revenue, you multiply. 10 packs at $4 is $40 in revenue. 20 packs at $4 is $80 in revenue. 30 packs at $4 is $120 in revenue, and so on and so forth, all the way down our chart here. Now, if you wanted to go back to average revenue, you would take your revenue figure, divide by quantity. So $40 of revenue divided by 10 units, $4 average revenue. $80 revenue divided by 20 units. That's $4 average revenue. It's $4 all the way down. It's just everything is 4. Everything is 4. Now, let's do the marginal calculation, which for our perfect competitor here, spoiler alert, will also be the number 4, but not for other market types we'll look at. So to do a marginal, which might be brand new to you anyway, we have to divide 2 changes by one another. So our first one here is our change in total revenue. So our delta here, what that denotes is we're asking, as we go 1 row down, how does our revenue change? So row 1 to row 2, revenue goes up $40. Next row, $40. We're just looking at the increase, not the total. Next row, 80 to 120, $40 increase. It's always a $40 increase, right? That's the perfectly competitive firm. Every unit we sell just sells at the same price. So we fill this in, we get $40 all the way down. Special note here, I can't do that for the first row because there's no previous row to go back to. Or in other words, when we calculated delta, you might think of that as the increase in between 2 rows. Like this 40 refers to going from 40 to 80. This 40 refers to going from 80 to 120. But a much more common way of writing that is that we put the change with the second of whichever 2 variables we're looking at. This will become more obvious when we look at some other changes today, where the numbers will actually be different, right? So let's do the same thing with our change in quantity. Again, super predictable pattern here. Each row, we're looking at 10 additional units being sold. So the delta is 10 all the way down, except for row number 1 because we can't define it. Marginal revenue is always a delta over a delta, change in total revenue over change in quantity. So we're saying, now let's take it down to 1 unit, right? Like this change in revenue here, plus $40, that's for 10 more packs sold. Let's take that down to 1 more pack sold. This is $40 more for 10 more packs sold. 40 divided by 10, $4 per additional pack. $40 per 10 packs sold, another $4 per pack, $4 all the way down. We already saw this coming. Marginal revenue and price is the same thing, only for competitive firms. If we had, a raspberry monopoly, then selling more raspberries would actually have an impact on the price for raspberries. Numbers would be a little bit more complicated. That is in our future. We're still a little while away from a situation like that. Okay, so this is revenue on an average and marginal revenue basis. You've probably gotten the point by now, but I just have to warn you one more time. So right now in perfect competition, price, average revenue, marginal revenue, all the same thing. Warning, warning, not necessarily always the same thing. Like price and average revenue, very often the same thing unless we're charging different prices to different people. Price and marginal revenue being the same thing. Oh, that's a special case. That's for price takers only. Okay, let's play the exact same game over on the cost side. So once again, we want to define an average. We take some total amount divided by quantity. But if you recall with our cost, we actually had more than one perspective there. Yes, we had our total cost, but we could also look at that just separately as just the fixed or just the variable cost, which means each of them has their own average to go with that. Average total cost divided by quantity. Average fixed cost divided by quantity. And you guessed it, average variable cost divided by quantity. Along with that comes standard acronyms, ATC, AFC, and AVC. So let's run through this calculation on our cost table. Here's the cost table we looked at a minute ago. Fixed costs, $62 all the way down. And then variable costs that will vary all the way up to a total cost, high point of $400 in this particular table. So to work out the average for each of our columns here, you take that column and divide it by quantity. So for example, average fixed cost, easiest one, it's always the number 62, but divided by an ever increasing quantity. So of course you take that division, you end up with a bit of a pattern here. You take a fixed number divided by an ever bigger quantity. The result, the average, will necessarily get smaller and smaller and smaller. First row again, undefined, because no division by 0 is permitted. So while today we're talking about the mechanics of how do we get to these numbers, I also always like to give you a little preview of, so what's this good for, so that you can start sorting it into a mental model of a business. Average fixed cost explains why some businesses have to be very large. Basically, some businesses have a large fixed cost. And if that's the case, in order to be competitive, you must be making a lot of product in order to spread that fixed cost out over all of those units, or otherwise you're not cost competitive. Imagine, for example, you run a cell phone network in the United States. And I don't mean you're like a value-added reseller. I mean like you're one of the companies that has the receivers on the towers. Well, you have to cover the entire country, which is big. So that's a huge annual cost in maintaining the network. You need millions of customers to be anywhere near competitive. That's why those sorts of cell phone companies only come in huge. Other businesses aren't like that. Fixed costs aren't this dominating aspect of the business. With businesses, for example, where a lot of the cost is coming from the labor side, which is a variable cost, you often see businesses that can be successful at very small sizes. So let's talk about some labor-intensive things. Let's say you're running some landscaping or snow plowing, or you're doing cosmetology or barbering. With labor being the huge set of the equation here, you can have a hair salon that's a very, very small business and it works. So that's where average fixed cost comes in. Average variable cost also has an important function. So again, we take the variable cost divided by quantity. First row, undefined, of course. Beyond that, notice average variable cost, they can go down, they can come back up. There's no guaranteed pattern there. Down and then back up is actually very common, but not a guaranteed pattern. Average variable cost will tell us the conditions under which we want our business closed versus open, shut down versus operating. Do you want to be open at night? Do you want to be open in the off season? Those are the decisions you make on the basis of average variable cost. And then finally, average total cost. So again, you take your total cost, you divide it by the quantity of production. Or you might have noticed, hey, you can actually get there a second way. Since total is the sum of fixed and variable cost, so average total is the sum of average fixed and average variable cost. So you can sort of check your own work here. You know, your total cost, 90 divided by 10, that gives you $9. But $6.20 plus $2.80 also gives you $9. Of course, there can be a slight offness by rounding here. Let's look, for example, at row quantity 70. 89 cents, 183, that adds to 272. So that lets you know there was a later digit 5 here that rounded up for both, sort of by happenstance. So sort of we go 1 cent over. But big picture should give you the same number both ways across. We will use average total cost to decide where to get into business and where to get out of business. Now, let's have a look at per unit cost from the marginal perspective. So I can't emphasize enough. This one is big in economics. We make many good decisions at the so-called margin. But good news, there's only one of them, not three. So what's going on there? Well, marginal cost is of course defined as the change in total cost divided by the change in quantity. So you might be asking yourself, well, why not do that for fixed or variable? Well, think about what marginal fixed cost would mean. What is the change in our fixed cost? Well, doesn't change, right? So marginal fixed cost is a concept that's just zero. It just doesn't make sense. And if that's the case, then marginal cost is the same whether we're talking about change in total cost or change in variable cost. So you could define marginal cost as the change in variable cost over change in quantity instead. Basically, nobody does that, but you ever play around with the tables, you do in fact get the same results. However, since marginal cost actually is going to change around a little bit for this business, as opposed to that marginal revenue that was just constant at price, let's take this opportunity to look a little bit more at calculating a change at the margin. So here we have our total cost. And we want to calculate the change in this number. So like we've done with total revenue before, we are looking at the increase in each row, but it's no longer the same number. Going from shutdown $62 cost to $90, it's $28 increase. 90 to 110, that's $20 increase. 110 to 126, that's $16 increase. And so on and so forth. So now you got to, properly associate 62 to 90. This number is associated with the change between these two. We typically put it in the second row. $25. That's the increase in cost going from selling 60 to 70 packs in raspberries. So this is our change in cost, but it's not quite what we call marginal cost yet, because marginal cost is defined as the change in cost for selling one more. And here, these rows, this is our change in cost for selling 10 more. So we need change divided by change in quantity. Each row we go down this table represents a 10 unit increase. So this is very often that change in quantity is just a constant number all the way down. Doesn't have to be. We could have some crazy cost table here where the quantities go 10, 15, 35, 50, 55, right? Then your changes in quantities would actually be different numbers. All right, marginal cost then. Here's our first increase in cost, $28 increase in cost for 10 units. That means per 1 unit, so 28 divided by 10, marginal cost is $2.80. That means as we increase production from 0 to 10, per pack we're selling, our cost is increasing $2.80. Then we notice as we sell more packs, our costs keep going up, yes, of course, but less so. And then as we start hitting that part of our total cost where the total costs start going up very quickly again, marginal cost starts increasing quite quickly. In fact, because marginal cost is calculated, at the margin, one step at a time, it can reveal big changes. Like we go from 0 to 10, each additional pack costs us $2.80 to sell. By the time we're going from 90 to 100, we're looking at like 4 times as much of a cost increase per pack. That's going to be relevant. We really want those stepwise figures. Okay, we've got our cost now. We can average, we can marginal. And on the cost side, totally not simply the same like they are on the revenue side. Which means we can now tie things up, tie them together, and talk about profit in the same way. We started today out talking about profit at the total level. Reminder, profit is total revenue minus total cost. But let's look at that on a per unit basis now. What sort of per unit basis? You guessed it, on average or at the margin. So conceptually, average profit is your profit divided by the quantity of sales. But let's do the math here and see what comes out. If we take our average profit, so profit divided by quantity, if we take our total revenue and our total cost and divide them by quantity, 2 familiar things fall out. Average revenue and average total cost. Only most people don't call it average revenue, they call it price, because for all single price companies, average revenue is price. So more commonly written, average profit is price minus average total cost. In fact, if the price isn't the same for every unit of your product, then the whole notion of talking about average profit per unit becomes a little bit more complicated, because, is that still being descriptive if you have low profit and high profit for different units of the same type? Okay, now let's look at marginal profit. So again, you could define this. Change in profit over change in quantity. A marginal just means change in the thing over change in quantity. But again, we apply that to the profit formula, total revenue minus total cost. Well, let's talk about our change in total revenue over change in quantity and our change in total cost over change in quantity. Once again, two by now familiar formulas. These are simply their respective marginals. So marginal profit can also be calculated as marginal revenue minus marginal cost. Notice I'm not substituting price for marginal revenue here, because even though I could for the very specific case of perfect competition, that will be very narrow. We're going to be looking at many other types of businesses as well. So we're going to leave that as marginal revenue. And if you want to not substitute price in here and leave that as average revenue, that's totally fine as well. Okay. So we're now going to look at profit on a per unit basis for our Raspberry farm. And again, while we could calculate this from first principles, profit divided by quantity, change in profit over change in quantity, we're not gonna. I'm gonna give you a table that only gives you averages and marginals. Let's look at the averages first. Average profit. Price minus average total cost. Okay, can't do that for the first row, obviously. Let's go one down. $4 price for 10 packs sold, $9 cost per pack on average. We're losing money. On average, we are losing $5 per pack sold. Economists will also refer to losses as negative profits. Now you see why. This continues to be the case for as long as the average cost of a pack is higher than the average revenue of selling it, right? So we end up with that same dividing line as we did on our earlier chart. Somewhere in between selling 30 and 40 packs, the price of a pack starts exceeding its average cost and we are in profit positive territory. Average profits climb and shrink again until we're back to break even. Price equals average total cost at 100 units. And if this table went beyond 100, we'd start going into those negative profits. So that's the average perspective. The marginal is very special. Let's look at the marginal. So here we're also looking at per pack, but we're saying per pack, like that pack, how much revenue does it bring in versus how much does that pack cost? Not a pack on average, that pack. Okay, so perfectly competitive company. We can't influence the price of raspberries. Each pack is bringing in $4 totally constant. But the marginal cost, you can start telling right from shutdown to selling our first 10 packs, those 10 packs already bring in more than they individually cost us to produce. So even though we're still in loss-making territory, we're already digging out. And as we start going down our table here, at first, that change starts getting even bigger, and each additional pack puts more and more into our pocket. Until we reach a point, you might anticipate where this is going, where the cost per pack starts climbing, and now we're selling packs where the incremental cost is equal to the incremental revenue. They've stopped contributing to our profit. You look back to the table from the beginning, that's the point where our profit stayed flat for one row. And then the profits start declining as additional packs cost more than they bring in. So let's look at this from the marginal profit perspective now. marginal revenue minus marginal cost, difference between these numbers. At the beginning, when we start producing, this is a positive number. So our profit is rising. Starts out at a negative number, but is rising until it maxes out, and then it starts falling again. And even though technically profit maximization is the next module's topic, you can already see where it is. And I want to highlight, by looking at one step at a time, just how much information a marginal can pack in. And for that, let's look at the final row where we're back to break even. And then we go one step back to 90 units of production where we're making a little bit of profit. So here, if you were just looking at averages, you might say, hey, selling raspberries for $4 a pack, on average, I'm making $3.29 in cost on here. So that's 71 cents profit in my pocket. I'm earning a profit. Like, good choice, right? Well, wrong. But that's where the marginal comes in. By looking at the marginal, it is revealed that even though on average, a pack may only cost you $3.29 to produce, by the time you're making 90, each additional pack is costing you $6.60 to produce, more than you're selling them for. And that's what matters, that the additional packs aren't worth it. At least when it comes to setting how much production level you want. And then, of course, very dramatically at the end, at this point, they're increasing our cost at $10.40, so total nonsense there. And as excited as I am about marginal, again, buddy with average. Average has its own helpfulness. We look at our beginning of the table here, going from 0 to 10 units. Hey, bringing in $4 extra per pack. Each additional pack only cost me $2.80 to produce. Very nice. My profit is positive at the margin. That doesn't mean I'm actually making money yet, because if we look on average, I'm still in the red. So while the marginal here is super good at finding that ideal level of production, it's entirely possible that even at the ideal level of production, we're not making money. We need both of them in combination to get a picture of our business. But all those wonderful decisions, we'll distill them down into 4 great rules for running your business, and that's going to be for our next module. For today, I hope you've learned something, and at this point can describe perfect competition, define total revenue, total cost, and profit, calculate average and marginal revenue, cost, and profit, and analyze a little bit how revenue, cost, and profit behave on average and at the margin. I will see you next time.